sorry. Okay, guys, let's continue from where we stopped. Now, how do we differentiate? Like, we have some trigonometric function, so I'm gonna write out some derivative of some trigonometric function. Okay, so we have y equals cos x. Okay, so the derivative of cos x, that will give us negative sin x. Take note of that. So we have y is equal to sin x. So the derivative is equal to tan x. Okay? So sorry, the derivative is cos x. I'm very sorry for that. Then if you have y is equal to tan x, so the derivative is sec square x. Alright? So these three main trig functions. So that's how you differentiate them. If you differentiate cos x, you have negative sin x. If you differentiate sin x, you have cos x. If you differentiate sin x, you have sec squared x. Okay, so take note of that. Now, let's do some what's it called? Some methods of derivative. Substitution method. And then the use substitution is called the chain rule. You understand? The chain rule. So when you have this kind of function, you have function y equals f of then g of x. Like you have a function inside another function. That's chain rule. But we're not making use of chain rule to differentiate this kind of function. Do you understand what I'm saying? You have a function inside another function. So you make use of chain rule to differentiate this kind of function by making substitution, right? So what kind of substitution are you making? You can say, let u be equals g of x. So if u is equal to g of x, you differentiate. So the u dx will be equal to what? G prime of x. That is when you differentiate this with respect to x, we have g prime of x. I hope we are together now. So then you come back here, so we have y is equal to f of u, since g of x is now u. So you differentiate this with respect to u. So we're gonna have the y over the u equals f prime of u. Are we together? Then the y dx is equal to chain rule, that's what we're using. So the y dx now be equal to the u dx. Then multiply by the y over the u. Okay, so the u dx is g prime of x. Then the y over the u is what? F prime of u. So this will be equal to, and don't forget, u is g of x. So this is equal to x multiplied by f prime of g of x. Alright. So if you have this kind of function, this is how you're gonna differentiate that. Okay guys, now let's do some examples related to this. So example 1, if you have y equals sine 2 of x, so find the y, the x. We have y equals sine 2 of x, so find the y dx. So how do we do that? So we said let u be equal to this 2x inside the brackets. Alright? Then you find the u dx. So the u dx equals, if you differentiate 2x, I taught you that the other time. So if you differentiate 2x, so we're going to have 2. Okay? Then you come back here, so we have y equals sine u. So instead of you writing 2x, you write u. Then we have the y over the u. Don't forget, we're going to differentiate sine u, so you're going to get cos u. Okay? So this will be equal to cos u. So according to your chain rule, I said the y over the x equals the u over the x multiplied by the y over the u. So the u over the x is 2, and the y over the u is cos u. Then remember, you can't stop here. You have to input back the original function of u. And we know u is 2x. So we have the y over the x equals 2 multiplied by cos 2x. I hope we are getting it, guys. I hope we are getting it. Okay, guys. Now let's move on. Good. Example 2, if we have y equals, let's think of another function. We have tan sine x. Look at this. We give it a trial. Yeah, you have y equals tan sine x. Give it a trial and let's see what we're going to get. We have y equals tan sine x. So how do we differentiate that? How do we differentiate that? Can we do that? So let's count 1 to 5 for that. 1, 2, 3, 4, 5. All right, let's do that together. So we're gonna say, let u be equal to sine x. Okay? So if u equal to sine x, so we're gonna have the u over the x equals cos x. Then come back here. So we have y is equal to 10u. Then you find the y over the u. So if you differentiate tan u, you're gonna get what? Sec square u. Take note of that. So this is gonna give us sec square u. Then we said the y over the x equals the u over the x multiplied by the y over the u. So the u over the x is cos x, then the y over the u is sec square u. And remember, u is sine x. Okay? So you have to input back the original function of u. So we're gonna have the y over the x equals cos x multiplied by sec square sine x. And that is the answer. Okay? So if we differentiate tan sine x, we're gonna have cos x sec square sine x. I hope we are together. All right. All right. Now let's do another example, guys. Please, if you are new to this channel, don't forget to subscribe. Don't forget to like. Don't forget to comment and also share. Okay. Now let's do another example. We have y equals exponential times natural log of x. Look at this. Look at this function. You have y equals exponential times natural log of x. How do you differentiate that? How do you differentiate that? Yeah, it's not something that is hard. It is very straightforward and easy. You understand? Okay. Don't mind my car. I hope you love it. Okay. So let's go on. So we can say, let u be equal to tan natural log of x. So we have u is equal to tan natural log of x. Alright? So how do we differentiate this? How do we differentiate this? We're gonna make use of another substitution. So we're gonna say, so you can use k, you can use any variable you like. But I'm gonna make use of lambda. So I can say let lambda be equal to natural log of x. Okay? So if lambda equals natural log of x, so we're gonna differentiate this with respect to x. So we're gonna have the lambda over the x equals 1 over x. Remember, if we differentiate natural log of x, we have 1 over x. If we differentiate natural log of x, you have what? 1 over x. So take note of that. Good. Then you come back here, we have u equals 10 lambda. Don't forget, natural log of x is now lambda. Then differentiate this with respect to lambda. So the u over the lambda equals sec squared lambda. Beautiful or not? So beautiful. So we're gonna find the u dx. So the u dx is equal to what? The lambda dx, then multiplied by the u, the lambda. Now, what is the lambda dx? The lambda dx is 1 over x. Then what is the u, the lambda, which is what? Sec squared lambda. Alright? So where your lambda is natural log of x. So we're going to have the u dx equals 1 over x multiplied by sec squared natural log of x. That is the u dx. But we want to find the y dx, not the u dx. So you come back here, we said everything right here is u. So you come back here, so we're gonna have y equals e raised to the power of u. Then remember, if we differentiate exponential x or exponential u or any variable, still going to get exponential u. The derivative and the integral is the same. It's not changing. It's I don't want to change. All right? That is exponential, but I don't want to change, and it's not changing. If we differentiate it, it's e raised to the power of u. If we integrate it, it's e raised to the power of u. It's not changing. Okay. So the y, the u is still e raised to the power of u. Okay. So we can now find the y dx. So the y dx equals the y, the u, then multiply by the u, the x. So what is the y, the u? E raised to the power of u. Then what is the u dx? This is this guy. We have 1 over x sec squared natural log of x. Alright. Now, what is u? U is what? Tan x ln x. So you put it there. Therefore, the y, the x equals e raised to the power of tan natural log of x multiplied by 1 over x multiplied by sec squared ln x. That is that. You can see. Very beautiful and straightforward. I hope you are getting it. Okay. All right. That's about that. That is about that. Okay. Now let's do one more function one more method before we move to the next method or rule. So here's another rule. Before we move to another rule, let's do another example. If you have y equals x plus 2 raised to the power of 4. So find the y dx. Find the y dx. Okay? And the y dx. If y equals x plus 2 raised to the power of 4, find the y dx. Now, how are you going to do this? If it says should be expanding, this is going to take your time, Yes or no? It's going to take your time. If you ask to be expanding, then it makes your substitution. So it said, let u be equal to x plus 2. Then you differentiate. So we have the u, the x equals 1. Don't forget. You differentiate x plus 2, that will surely give us 1. I think you understand now. So you come back here, you have y equals u raised to the power of 4. Then the y, the u is equal to what? If you differentiate u raised to the power of 4. So that's going to give us 4 divided by u raised to the power of 4 minus 1. And what is 4 minus 1? That's 3. So this is 4u raised to the power of 3. Good. So then we have the y over the x equals the u dx, then multiplied by the y over the u. So the u dx is 1. And then the y over the u is what? 4u raised to the power of 3. And what is u? Remember, u is x plus 2. Okay? And then 1 times 4 will give us 4. So we have 4 into brackets x plus 2. Then you can see to the third power. So that is the answer to that. Are we together, guys? Are we together? All right. All right. So let's do one more example. If you have y equals sine squared x. Look at this. You have y equals sine squared x. How do you differentiate it? That's cool. So you mix up your substitution. You said let u be equal to sine x. Okay? Then you find the u dx. So the u over dx will be equal to what? If you differentiate sine x, you are going to get cos x. So this will be equal to cos x. Then you come back here. We have y equals, sine x is u. So you have u raised to the power of 2. Then the y over the u will give us what? 2u. Okay, you differentiate u squared, translate u. So you have 2u. Good. So we're going to have the y, the x equals the u, the x, multiplied by the y, the u. So the u dx is cos x, and then the y du is 2u, and remember, u is sin x. So this will be equal to 2 cos x sin x. Alright? So which is equal to 2 cos x sin x. Very, very beautiful. Very, very beautiful. You know, these are, you know, your trig identity. You should remember your trig identity. What is sin 2 theta, everybody? What is sin 2 theta? The trig identity, you know, sin 2 theta equals sin theta plus theta, alright? It means theta plus theta, 2 theta. And then, if you remember from your trig identity, if you remember, we know that sine A plus B will give us sine A cos B plus sine B cos A. Remember that? So sine theta plus theta, your A is theta, and at the same time your B is theta. So this will be equal to sine theta cos theta plus sine theta cos theta. So which is what, you know, I said A is theta and B is theta. So we have sine theta plus theta. So theta plus theta will give us sine 2 theta. So we have sine 2 theta is equal to what? You know, sine theta cos theta plus sine theta cos theta. That will give us 2 sine theta cos theta. That is beautiful, and that's what we're going here. 2 cos x sin x. So that shows that this is equal to sine 2x. I hope you guys are getting it. I hope we're getting it. Okay? So that is beautiful. That's the beauty of maths. Oh, mathematics is very beautiful and interesting, isn't it? Yeah, it's very beautiful. Alright. So that is that about chain rule. Okay, so let's talk about the product rule. Product of two functions. So it's on this form. We have y equals f of x multiplied by g of x. This is a function f of x. Here's another function g of x. Product of function. So how do you differentiate products of two functions? How do we differentiate products of two functions? So after this, we're gonna stop for today. Okay. So in our next slide, we're gonna do more. Okay. So f of x multiplied by g of x. How do we differentiate that? Now, this is how you do it. You can say let u be equal to f of x, and then let v be equal to g of x. Okay? Then the u over dx will give us f prime of x, and the v over dx will give us g prime of x. Then the y dx will give us what? V multiplied by du dx plus u multiplied by dv dx. So this will now be equal to your v, which is d of x, then your du dx, which is what? F prime of x, plus your u, which is what? F of x, and your dv dx, which is what? G prime of x. Take note of that. That's the formula you're using for product of functions. Alright? So you have f of x dot g of x. So that's going to give you what? If you differentiate that, you're going to have g of x, f prime of x, plus f of x, g prime of x. Take note of that. So y prime equals g of x, f prime of x, plus f of x, g prime of x. Now let's do an example on this. Let's do an example on this. Now, example 1. Let's say we have y equals sine x tan x. So we want to find the derivative. We have sine x tan x. We want to find the derivative. So how do we find the derivative? So your the y dx will be equal to what? Now g of x, which is tan x, multiplied by f prime of x. That is, if you differentiate sine x, what are you going to get? You're going to get cos x. Okay? Then plus f of x, which is what? Sine x, multiplied by g prime of x. That is, if you differentiate tan x, what are you going to get? You get sec squared x. Isn't it beautiful? So this will now be equal to now. Remember, we can still simplify this further. Remember that tan x is equal to sine x over cos x. So that is sine x. Tan x is sine x over cos x. Then multiply by cos x plus sine x multiplied by, sec square x, that was 1 over cos square x, because sec x is 1 over cos x. Are we together? So sec square x will be 1 over cos square x. Okay? So therefore, cos x will cancel out cos x right here. So what you have now is what? Sine x plus, sine x over cos x multiplied by 1 over cos x. Do you understand what I did? I splitted 1 over cos square x as well. So 1 over cos x times cos x. Then sine x multiplied by 1 over cos x will give us sine x over cos x. And then sine x over cos x will give us what? Tan x. Okay? So this will be equal to sine x plus tan x multiplied by 1 over cos x. And 1 over cos x is what? Sec x. Okay? So that is the answer. Therefore, the derivative is sine x plus tan x multiplied by sec x. So that is our thing about that. I think we are going to stop here for today. So next time we're gonna meet, talk about more on products of function, okay? And then we talk about more rules in what? Differentiation. So if you like this kind of video, please don't forget to subscribe, like, comment, and also share with friends. So thanks for watching. See you next time. Goodbye.